Okay, hello and everyone to the section of video in which I am discussing about the replication in prokaryotes. Alright, this is the process of initiation of, this is initiation of replication in prokaryote, and this is a typical example of E. coli. We know that E. coli is having a rounded DNA, right? It is round in shape, and then for example this is the ORC, this is ORC, and if the replication will start from here, then what happens, it will be starting from both the side, it will break from both the side and it will meet somewhere here, and at the end what it will form is, it will form this kind of structure which need to be broken later, and then they will separate from one another, right? What, like it will start to make from this side of replication fork, and this side of replication fork will start to make from this side, and finally they will form a duplicate DNA, and they will be in this fashion, and later they will have to be separated and they will live individually. All right, so now we are discussing about how this origin of replication is formed, how this replication bubble will be formed, will be discussing in this particular video. Now first, there is in the origin of replication, the origin of replication in E. coli is known as OREC. Alright, it is known as OREC, and the OREC is rich in 80 base pair. Alright, and this region is having 13 base pair repeats. Alright, 3 repeats of 13 base pair. OREC is having 3 repeats of 13 base pair, and near to OREC there is another region known as replication recognition sequence. Alright, these replication recognition sequence contain 9 base pair, 5 sequence of 9 base pair. Now, why is it important to learn about the replication recognition sequence? Because this is the origin of replication. Replication bubble will be forming here, replication will be happening here. Why is this important? Because this is the region where the first protein which is responsible for the initiation of the replication will come and bind. The first protein, that is DNA, which is responsible for the replication, will come and bind to the 9 base pair region. This is because it can recognize only this replication recognition sequence. The first protein, that is DNA, cannot recognize the 13 base pair sequence, that is origin of replication, directly. It can recognize only replication recognition sequence. So first, this is DNA, it will come and sit in the replication recognition sequence. When it will sit in the replication recognition sequence, then what happens is it will form somewhat this kind of a structure. Alright, due to the binding of DNA, what happens is there will be the pressure to the DNA, and the DNA will form a negative supercoiling, and due to the pressure, what happens, the bond here in the 13 base origin, this is OREC, the bond here will be melted. Alright, AT bond over here will be melted in the OREC region because of the pressure created here due to the negative supercoiling. The OREC will be broken now. When the OREC will be broken, then they will start melting and they will start forming a replication bubble. They will start forming a replication bubble. This replication bubble will be recognized by another protein complex, that is DNA B and DNA C. Alright, and they are in this kind of fashion: 1, 2, 3, 4, 5, 6 subunit of DNA. This is DNA B, and 6 subunit of DNA C. 1, 2, 3, 4, 5, 6. This is the DNA B and C complex. These will come and sit over here, one of the strand. This DNA B and C complex will come and sit in the one of the strand, and those they start to unwind the DNA, and the replication bubble will be more bigger in size. Right now the replication bubble will be more bigger, since they will be sitting here and they will be start to unwind the DNA. Replication bubble will be more big. Now why I have not drawn this C? Only I have drawn the black one and not the blue portion, because the C will fall off. DNA C will fall off as soon as B will bind to one of the sequence, because this DNA C is just helping the DNA B to recognize the replication bubble or the melted portion. After the DNA B recognizes the melted portion, the DNA C will just fall off. You can, in one diagram, first you can draw this. DNA C is sitting, and when the replication bubble is getting more bigger, now you need not to draw the C, only DNA B. Now DNA B is nothing but it is helicase enzyme, so it will unwind the double-stranded DNA and it will enlarge the replication bubble furthermore. Now again another enzyme known as DNAG. DNAG is a primase which will come and which will anneal the primer. DNAG will do the primase activity, that is it will anneal the primer and it will lead to the synthesis of the new strand. Right? The primer will lead to the synthesis of new strand, right? Let us not draw this strand now, because we will be studying about the elongation of this strand in next video, in the elongation section, where there will be DNA polymerase 3 employed for this. But DNAG is another enzyme which, after unwinding of DNA and the increase of the replication bubble, will come and ligate or anneal the primer, RNA primer, which will initiate the process of elongation with the help of enzyme polymerase, DNA polymerase 3. Now this was only the thing. What happens is, first there is a replication recognition sequence which is made up of 9 base pair and 5 repeats of 9 base pair, and then 13 base pair repeat of 3 sequence. And then what happens is, first this is known as replication recognition sequence. In replication recognition sequence, DNA A will come and bind. Due to the binding of DNA A, it will be creating a negative supercoiling and pressure in the AT rich region, that which is the origin of replication, and due to this the AT rich region will melt, and the melting of AT rich region will lead to the formation of the replication bubble. And as the replication bubble will be forming, what happens? DNA B and C complex will recognize the bubble and they will come and sit in one of the strand. DNA B and C complex, they contain 6 subunit each, and They are made up of 6 subunit each, and they come and sit in one of the strand. As DNA B and C complex recognizes the strand, DNA C will fall off because it will be not having any further work apart from recognizing the sequence, and then only DNA B will work as a helicase and unwind the DNA. Now as the DNA is unwound, another enzyme known as DNA G will come and sit in the replication fork and anneal the primer for the synthesis of DNA, right, for the process of elongation. This was only for today. Thank you.